Welcome everyone. For everyone watching this video, also welcome in the future. This workshop is part of the SCRT Labs Perps Hackathon. I'm personally from the Secret Network Foundation. My name is Alex. I'm a DevRel at SNF, so the Secret Network Foundation, and I'm basically working together with Secret Labs to do this workshop today. So we discussed everything. I also got help from myself to do the presentation as well. Sadly, he can't join today, but if you have any questions, feel free to ask Secret Labs about it. And of course, me as well, or Sean Rad, or anyone else from Secret Network Foundation or from Secret Labs that that think you can help you. So for today's topic is advanced contract development. And the idea behind it today is to give you, some ideas on what you need to, think about when doing contract development. We're not doing specific coding today. It's more of like what things do you need to keep in mind and what code examples can and should you use as much as possible to save yourselves a lot of time and most of the time headache as well. So let's get started. So main reason why we need to do all of this extra stuff. Why do you need to think about privacy while writing smart contracts? The main reason is obviously we're using trusted execution environments to do our smart contract execution. So everything outside of the TE is encrypted, and we have encrypted states. So that means that we can't just look into some state and say, oh, what happened here or what happened there. That's just simply impossible. You basically have to be able to get data and get information out of the smart contract in different ways. For example, balances, who's an owner of, like, for example, an NFT, and some stuff like that. And you have to think about special ways on how to handle this. So simply just looking at balances that are public is not possible in secret. And for that, we basically need to think about, okay, now that we have this, how do we do DeFi in secret then? Because if stuff isn't completely public, what can you do and what should you think about? So for handling DeFi, especially makes a lot of sense if you're talking about perps in the hackathon. What do we need to know for programming if you want to do like proper DeFi in secret? First of all, you need to understand and handle secret network improvement proposal 20 tokens, so SNP 20 tokens. What are these, and what you need to think about it when you handle these? Next thing is, if you have SNP 20 tokens, you need to also think about what viewing keys and permits are. So, for example, you want to access these tokens or you want to access certain positions. You need to think about access control. If stuff is encrypted and you want to keep the stuff private, there has to be a way to keep the stuff private only to you. And viewing keys and permits are a way to make sure that only you can see what you actually are supposed to see for yourself. So the access control stuff, that's important. Then when handling DeFi as well, the next thing you should keep in mind is, since Secret is like an array of like privacy preserving smart contracts, has like tons of features. I think most of, new programmers would struggle to implement basic stuff. So that's why Secret Labs actually developed the SecretToolkit to help you with this. And it's especially valuable if you know how to use it to your advantage, because otherwise you will be wasting a lot of hours like just trying to get the basic stuff working, while SecretToolkit basically has everything at your tips. From encryption to handling SNPs to almost a lot of stuff that's pretty specific to Secret. And then lastly, I just want to quickly go over some common pitfalls that I remembered when you write privacy preserving contracts. Stuff that you basically need to usually don't think about when you do like public contracts and don't really really care about it. But as soon as you have like private contracts, you need to care about, because stuff can leak, potentially information can leak, and debugging is also a bit harder. So I think that's all about you need basically for handling DeFi, and that's basically that's basically the things you need. So let's get started. How do we handle SNPs? SNP 20s. The SNP 20 standard is essentially the same as the ERC20 standard in Ethereum. So it's the idea behind it is it's obviously named after it. The SNP 20 standard is like the pendant to the ERC20 standard, and it essentially gives you tokens that live on secret. So, for example, secret USDT, secret USDC, for example, even a secret version, and so on. Several improvements have been made, mainly bug fixes and also adding permits, for example, or decoys, such as these things. So like extra features have been implemented into SNPs, and SNP 26 is the latest iteration of it. So several improvements have been done, and the latest one is SNP 26. Yeah. Now the thing is, since this is also a contract, it obviously needs some special care, because you essentially don't just use public tokens as you would usually do in Cosmos, right? In Cosmos, you would usually do like a message bank message that you just say, okay, just send around some tokens or transfer around some tokens. Thing now is, if you are in secret and you handle these SNP 20 contracts, you basically just have contract interactions. So if you have contract interactions, you need special care. Of course, if you have another contract who calls a SNP 20, you need to take some special care to make sure that it actually works, because message bank just doesn't work, as I said. Then the next thing that you should be keeping in mind for SNP 20s, what they have is viewing keys. So viewing key is a special thing that allows you to essentially view the balance of your SNP 20. So for example, you have 10 USDC, SUSDC, for example, secret USDC, and you want to see what balance you have. Then you would create a viewing key. So you do a transaction and that creates a viewing key. And with that, you can see your balance. Then what you can also have is permits. That is actually just something that you sign offline and you submit a signature to the contract with the query. So you basically query the contract and say, here I have a permit. Basically, it's a signature that proves that I signed this message. And with this message, it should allow me to view the balance of that SNP 20. So, and lastly, for the SNP, most important functions for the SNP 2x standard is essentially send. So what you can do is you can transfer funds to a contract and call a function on a contract. So that's basically what you have is, for example, you want to swap some stuff, you send basically these funds over into that swapping contract and call a function that says, for example, swap X to Y. Or for example, for a Perp hackathon, it would be, for example, you would basically send in some secret or like S secrets or some secret USDC into a contract and would say, okay, your contract, please create me like a position this and this with this and these parameters. And here's the token, basically the underlying collateral that I have for this. Or you want to like deposit more collateral or like withdraw collateral and so on. So each of these would basically use a send function. Then you also have transfer, which just transfers funds to an address, which isn't the most interesting. I think send is the most interesting for us. Now, let's get to viewing keys and permits. I think this is one of the most important things that people need to know when you're doing smart contracts, which is basically keeping in mind what permits are. And permits are extremely valuable because they can be signed offline on your device. So what you can do is you basically have it on your ledger. For example, you can sign the signature on your ledger or directly on your wallet, on a paper wallet, and it will just have like a signature within it, and that's already enough to have access to everything. You don't need to submit a transaction to a network, don't have to pay gas, which is super nice. You can have multiple permits simultaneously, so you can create multiple ones and actually distribute them across like people you trust. If, for example, you don't trust someone with a permit anymore, you can actually revoke this permit as well. So basically just you do a transaction and store inside of the contract that you invalidated like a permit. So that way you can revoke it. Also, for example, you can use one permit to handle multiple contracts to say, I'm basically giving one kind of master permit to handle multiple contracts and to have access. For example, if you have multiple perps and they are like all different trading pairs and they're like living on different contracts, you could still create only one permit that covers all of these perp contracts. So I think for most these perps, it would make a lot of sense if you use permits. On the other hand, though, permits are one of the newer things. You could also look at viewing keys, which is like the super old traditional way that happened in secret. And what you do is basically you send a transaction into the network that says, I want to set a new viewing key, or let's just generate a new viewing key. So it's actually a transaction that you need to sign and pay gas for. But what you have is you only, and that was one of the older things. That's why I basically said permits might be better for us, is that you only have one valid viewing key at a time. So you can only set transaction and say, I have this viewing key. This is the only one that's valid. You can't set multiple ones. But you can at least change it as often as you like. That's at least something that saves you. And at least you can revoke all viewing keys. But again, if you revoke it, it's revoked for everyone who has that viewing key. So it's there isn't that much of a fine-grained access control, even though it's still possible to rudimentary use it with viewing keys. But in essence, for perps, I would recommend using permits as much as you can, because that way you're pretty flexible in what you're doing. Only thing that you really need to do is you should probably just store the permit in some place, basically where the user can easily retrieve it and use it again, because that way you don't have to sign stuff each time, sign permits each time. You can basically just sign a permit once and save it for quite some time, and that way you would have a pretty good UX, while also being pretty secure, because the permit isn't forgeable because you have to sign it. So I'd heavily recommend using permits, but viewing keys is still an old relic of time, and you can still use it, of course. Now, after we have viewing keys and permits, we can actually look at stuff that you could do with a snip, which is sending, which is the send function, which is this one here. So I basically took the function definition out of SecretToolkit, and in essence, what you can do is, by sending snip 20 tokens is usually just a contract call. So what you do is you take your snip that has a contract address and that has a contract hash, and you take this one, and essentially you basically say, okay, your snip so and so, I'm gonna send this amount into like this and this perp contract, and I'm going to use, for example, and please listen this message on your contract. So for example, it would be the recipient is, for example, the perp contract that you have, then the amount is you can actually see this is perfect. You can actually see the amount here that basically you want to send into the contract, then the message that you want to give over in the memo. The padding is optional to ensure that the same message doesn't yield the same encrypted message twice. So a padding is usually random, whatever, 16 characters and so on. Block size you can pick. This is usually like a default setting, and then callback, code hash, and contract address. So you can do multiple. So basically, you can call this the next contract and for the callback code hash. So that way you can basically do whatever you need, just using SecretToolkit. So you basically need to define everything, and the SecretToolkit will do everything. It will do the rest for you. SecretToolkit, let's look at this example for later on in the code itself. I will basically go there and we can discuss this more. But in essence, SecretToolkit provides you is a pretty nice way to just simply have the snip stuff already, pretty conveniently available. So you just have to basically define the contract header of your snip, recipient amount, and just the basic stuff, and just don't have to handle anything else, because using a snip is actually contract interaction. So yeah, quite an easy, nice way to use snip 20s. Let's go further, which brings us to basically the SecretToolkit. So since snip 20s are easy to handle, using SecretToolkit, what else can you do? And SecretToolkit is essentially something that's pretty specific to Secret, because with extra privacy, you get the extra effort of actually making sure that stuff stays private, and that you have to do more encryption in all sorts of areas. And essentially, it's I'd say it's kind of the Swiss Army knife of handling, stuff that's with secret contracts. Exactly everything that you need for using SecretToolkit is mainly in the repo itself. So from Secret Labs wrote the SecretToolkit, so you can easily go to this link and look at their toolkit and check it out, what they have, everything in there. We also have some documentation across basically all pages that use a SecretToolkit. So thanks to Sean Redd, they basically contain a lot of super valuable information when it comes to when it comes to using SecretToolkit in practice, which can be basically anything, right? There could be interactions with SNP20s, it could be interactions with NFTs, so SNP 721s with secret NFTs, could be just some crypto primitives, for example, for encryption, some ECDH, for example, you can do with this. You can also do elliptic curve cryptography like SEC P256K1. Like everything basically that you need to do some signature verification and so on. So everything is there and able to be used pretty easily by just using SecretToolkit. So they prepped everything. It's working pretty nicely. And we have some extra docs at docs.rs. Just check it out and see what you can find there as well. But these are like quite some nice resources to using SecretToolkit, and this is a pretty good starting point if you, for example, want to see if you want to do like some encryption stuff or want to do like some extra verification of signatures and so on. This is basically the first place to go. Or basically, if you want to do some weird math stuff or whatever, I would first always try to look at SecretToolkit as well. If you can't find it in the cosmwasm standard package, obviously, and see if SecretToolkit has it for you, because I think at some point they almost every Secret Labs implemented a lot of stuff in all kinds of weird ways, because they used it for themselves, and basically that's how they got a lot of the interesting stuff built. So yeah. When using SecretToolkit and using SNP20s, I usually get the following problem. If you have contracts, what is the stuff that you really need to look out for when you have, let's say, the extra privacy added on top? Because usually if you think, for example, osmosis or so, or neutron, you just deploy a smart contract and you don't really need to think about leaking information because stuff is already public, right? You don't need to think about it, obviously. So what are some common pitfalls that I see that people need to look at when you really care about privacy in a contract? Because here it really matters what you do and what the outside actually knows of. First, I'd say one of the most important things is usually that the gas used kind of reveals what you're doing. So for example, if you just create like a swap, or for example, add liquidity, or create a position, like per position maybe, like some long or some short position, it could actually make a huge difference in the gas used, because of extra checks, because of like maybe funds that are sent into, maybe because of a SNP contract call as well. That makes a huge difference for the gas, and that kind of reveals what you're doing. So what I would suggest then is to use padding, so that artificially blows up the message itself. So basically the message length and the gas used makes a huge difference. You can use padding to blow up the message length, so that just adds some extra stuff to the message without actually being used. And if you want to really, waste gas, essentially, to conceal what your true transaction was, you can also use gas evaporation. Like that's a SNP50. That's another improvement that's been made by two very seasoned secret devs here, Darwin Zero and Subdoggy from Starshell. So basically, essentially, Starshell spearheaded the SNP50 development of gas evaporation. So if this is really something that you're really thinking about, concealing positions, especially, for example, if you want to conceal if you have a long or short position, for example, it could make a difference. Gas use could make a difference in what position you're taking. So to try to conceal that, it actually makes a lot of sense if you use gas evaporation, for example, to prevent this from happening. You basically wasting gas on purpose to just conceal what you're doing. And I would definitely recommend doing this if you have the time to implement it. because that way you would leverage privacy to the max. For example, then another thing, and that's another thing that you really need to keep in mind, is actually that you need to look out for essentially leaking your swap positions or your swaps or your liquidity providing by looking at basically just the total size before and after transaction. So what happens is you usually, for example, have like a pool size of, let's say, 100,000 on one side and 100,000 on another side of an asset. And after you do a swap, you basically, for example, do a pretty big swap. Then you have like 110,000 on one side and 90,000 on the other side of that, for example, that's that pool or so. And the thing is, if someone is actually smart enough, he just samples or just asks a smart contract often enough to say, please, contract, he just queries the contract and basically gets out the position, basically the total position. For example, the 110,000 to 90,000. And if you do this often enough, you can actually have like a pretty fine-grained view of what's happening. Because the thing is, as soon as the total position of that pool changes, he basically just needs to look at who interacted with the contract, and that way he can basically reverse engineer who actually did what trade or did this and this swap. So what you really want to do is you want to delay or obfuscate what you're doing. So you want to maybe like delay the reporting inside of the contract of the total size to make sure that people can't really do some time correlation on the size of the pool or the composition of the pool and the transactions that happened with it. Or you just obfuscate it by, for example, adding some random numbers to just give some band within where the pool is within. So they could also work, but just some ideas. But that way you don't leak any information on the side via sidebands, basically, like via like side channels. Then I would definitely make sure that actually, if you are looking to give people permission access to information, for example, on their swap position and so on, actually make sure that you have all checks correctly in place, because otherwise it looks like people would be using correct permits or viewing keys, and when in fact they're not. And then if the check is not correct for some reason, basically missed the correct check, then it will simply give people access to information that they're not supposed to look at. You can imagine that this is not good. So this is one of the other things. So just make sure, if you have permission access, actually make sure only the right people are supposed to look at, because you basically need to look at everything that is supposed to be able to be seen. And if you just say everyone can see it and just assume that there's no extra check, then obviously you would just leak everything out of the contract, and you don't even need privacy preserving contracts, obviously. So just make sure that you also have this set.
Do you have code examples for that check, Alex?
For the VCAM permit, yes, I have, because it's actually part of the SNP 20 definition. Just a reference implementation for permits and for viewing keys. So I would heavily recommend using these reference implementations for permits and viewing keys as well, if you want to add these for your perp contract, for example. So yeah, I think this is the one you want to refer to, Sean, right?
Awesome.
Yeah. I would definitely show this. This is one of the things I want to show in the code examples that I want to show afterwards, and just discuss, right, and just have some examples. But very nice point, thank you. And then one of the last pitfalls is usually the thing is that people are tending to use code quite inefficiently, which is usually fine if you have like an open, cosmwasm chain, because the execution is fairly fast, right? You don't have any Intel SGX encrypted, trusted execution environment that you need to, execute the stuff in. You usually just have a, simple execution in an environment that has tons of resources, right? Like, for example, in Osmosis or Neutral and so on, stuff is just handled by, what is it? I think it's wasmd for their, not quite sure what engine they use again. I think it's wasmd, just super plain, super easy wasm engine. Doesn't need anything extra like Secret does all the time. If you execute stuff inside of with Intel SGX, it needs extra care, so that's why. But the main problem right now is if you are quite inefficient with code, and have code that does like a lot of extra checks that's not needed, and is kind of unoptimized, then it will be a problem on secret. Because the thing is, if code isn't quite efficient, it will blow up the gas usage quite a lot, and it will also just slow down the whole network, because a lot of transactions take some computation time inside of the trusted execution environment, and stuff isn't as fast as you would be used to from Neutron, for example. So gas usage is a lot more sensitive. It's a lot more sensitive inside of secret if you use inefficient code. So make sure to use efficient code and actually not waste too many cycles on some useless computations, or like on 5 checks that are not needed, or for example on just inefficiently using variables. But of course, as with all DeFi stuff, you should be very careful when trying to remove any check. That usually can lead to some nasty bugs. And just because you use privacy doesn't prevent you from actually writing bugs that are exploitable. You just won't see it when it happens. That's one of the main things. So you actually need to keep in mind, right? That will be another thing that you should probably think about, is if there's an exploit happening in a swapping pool, you actually need to have some sort of way to kind of detect that some unusual stuff is happening, because it's not quite obvious from the outside, because you can't see the contract state since it's encrypted. So just keep in mind that detecting exploits is a bit harder, and you might want to actually implement some sort of like mitigation for this, to detect if like some unusual amount of like currency outflows happening, or if some have some sort of detection for this. That's actually also something I would recommend. Exactly. But I think that brings us to the last thing that I wanted to say for common pitfalls is, usually you have smart contracts on Neutron, Osmosis, whatever, that are public. So in case some stuff happens during the execution that didn't work, so whatever, wrong currency, amount not enough, something like this, or some check failed, probably like some over leveraged position or whatever, then usually you could just panic the contract, and you would kind of have easier way to maybe like find it, or like do some console log output or whatever, like something at least that's easier seeable and reproducible inside of public smart contracts. Problem is, if you have secret, stuff is of course encrypted. So the only thing that you're really gonna get is like a console output afterwards. So if the execution succeeded, you would just get like a code 0, that's fine. But if some stuff maybe failed, you need to actually be able to get the correct error message out. If you just use .unwrap, that's usually not enough, because it would just panic the contract if stuff isn't full, if it's not working. Which is obviously not enough really to have some sort of good debugging, because for example, you have 10 unwraps and you execute a function in a contract. For example, if you have 10 unwraps and one of them panics, you don't know which one it was. So you should really use proper error messages to make sure that you're really extracting the correct error message actually out when something happens, and just make sure that this is the case. This is just something that's in practice a bit harder with secret, because you only see the output of the execution. Is only the user sees the exact output of the console, basically of the execution output that he did. So if there's some sort of error, the user actually needs to decrypt his own transaction and actually needs to look at it, what happened, and then give you the info as a developer. So having proper error handling and messaging, that you actually need to get correct feedback from the contract is essential. You can't just panic the contract and say, oh well, I didn't know. But I think this is one of the most important things that I wanted to say. So just common pitfalls that you have when you handle privacy preserving contracts. And now I just want to discuss some smaller examples. So for example, as Sean's basically said, I can basically show you how it's done. And I can basically would give you these to your hand, and we basically talk about some. For example, we can handle some snips using the example from SCRT Labs, Netflix, which is like a decentralized Netflix version that handles snips, for example. So for example, you can basically buy some virtual or loan some virtual videos and pay it for using snip 20s. Then we have some examples from Sean Red, who did like an awesome job at compiling a lot of super valuable examples, even from privacy as a service to just handling, some snips and using viewing keys and so on. Then the SNP 20 reference implementation, which contains all of the information for viewing keys and permits, and then shared protocols on contracts as well for their swap and so on. So I'd first go into the SNP 20 reference. Let's see where our window is. Let's just go here. Let's see. I think that's quite good. Can you see it? Yeah, that looks good. Yeah. Okay. So if you look at the SNP 26, as you can see, that's the latest iteration right now. And we can go into the source and go into the contract RS and see what's happening here. As you can see, a lot of them is, of course, using SecretToolkit as expected for handling viewing keys and so on. And we can go down and look at the queries. Let's see. Of the query functions that we have. So, for example, there's like a lot of permit queries. Let's see what we can do as well. Exactly. So first we can actually look at the SNP 20 queries that we have, token info, token config, and so on. And then you can look at the queries with permits. For example, you can use permit queries, or you can use viewing key queries. And I would show you permit queries first. I think that's the most important. I think let's just stick to this. So I think this is one of the key functions that you can use to advantage if you want to do for Perps, for example. You can basically use this, how it's done here. I would actually recommend almost copying it one by one and just see what you want to do with it. But essentially, it's pretty easy. You basically get the token address here that you loaded from config and that you have inside of the contract. And what you do is you basically do some account verification. You basically use SecretToolkit to verify the permit that you have that's here. And you use this permit, you use SecretToolkit to essentially handle all of the validation for permits. So that way you have a pretty fast way to actually use everything with this. After this, you can use query. You just basically just do a matching the query that you want to do. So for example, you use balance, transfer history, etc. And in each of these, you really need to check, for example, if the permit itself is actually here. So this basically pulls out the permit if there's one and gives you the verification it actually worked or not. And as you can see, you also need to check though. So this gives you the verification, what stuff you can actually do. And here you need to actually check for each stuff that you want to do. For example, checking balance. You need to check if the permit itself actually has that permission to do balance checks, for example. If not, you send an error message. Otherwise, you, for example, query the balance. Same goes, for example, for transaction history. So, or transfer history or transaction, whatever you like more. For example, for transfer history, you do the same. You basically check if that permit actually has the permission to do this transfer history. And if it's inside of it, you query all the transfers. And if not, you return an error message. And that way you can do an easy check if the account is allowed to do it or not. As goes for the permit, let me see where I can give you the structure of it. I will probably also just add this to the presentation afterwards. But in essence, the permit essentially has a address. So essentially gives you, one of the key things of it is essentially you have you define permits for certain contracts, and you also define permissions for these contracts. So for example, I have this in this SNP 20 contract, for example, USDC, and I want to have a permission to view balances, to do transfer history, and so on. And that way you can easily wait a sec, let me drink something. And that way you can easily have a very fine-grained access control of what you want to show and maybe not show to others. So for example, you want to show like permits, you will show someone like a perp position, or you want to give the user a possibility to look at everything. You basically just make a permit that has all functions included and all possibilities here included in the permissions. But you can also do finer grained permits as well, for example, for support or whatever. Or you can use multiple permits. So that way you're completely free in whatever choice you want to do. And for viewing keys, you essentially have pretty much the same thing. In essence, you have the viewing key and you check the viewing key if it's correct. And if the viewing key itself is correct, you can basically do everything else that you want to do. But for example, you don't have as a fine-grained access control as you have with permits. Either you have a viewing key and you can look at everything, or you don't have a viewing key and you just can't. So permits are a lot better here if you want to really, do some finer grained access control. So I definitely recommend queries, and please use this example for the reference implementation. It's super valuable and it will save you a lot of headaches, especially when you use SecretToolkit, obviously, because permit verification is done with SecretToolkit and uses just some standard cryptography stuff, but it's a lot easier if it's already done. I think that's one of the other things. Maybe I can also show you the send function itself that we seen before. So as you can see, you have the function send, and you can basically here do a try send. So if you execute the message send, it will execute this function here, and we can jump to this definition here and exactly do which jumps to try send implementation. And this one is outsourced in a different part of the contract as I see it. No, it's up here. And exactly, then you basically have like a transfer plus some callback. So it essentially sends the funds to the contract and then actually calls that receiver with a callback to go back to the contract. So what you can do is here, you can jump to this as well. And here you actually call basically the other contract and get a callback as well. So quite some sophisticated stuff that's happening here, but I think that's a very nice starting point for everyone who wants to, play around with, sending some snip into a perp contract, execute some message there, and maybe like, for example, you send some snip into this and say, this is the collateral, I'm opening up a position of whatever. And this is exactly the way to go. Exactly, I think that's quite a nice way to do it this way. I think the other thing I wanted to show last was, let's see what we have as well. So for handling snips, this gives you a lot of nice things. Let's just show you the part from Netflix. So your access control, you can actually look at the access manager, which is just a set of contracts. And we have some execute here. So for example, in this contract, for example, we can get the implementation of snips. And as you can see, you can, for example, use snip 20s for example, in this function, for example, here you can purchase a video and it uses a snip 20 to actually create some royalties. And that inside of this function actually uses, as you can see, SecretToolkit to distribute royalties, and which is integrating with a snip 20 is simply using this function essentially. So you send some snip to a contract to the recipient of this royalty, and you just basically get yourself the amount that you have from the royalty, from that that you calculated. That's your royalty basically, and you use your token that you have. For example, in this case, maybe it would be SCRT, and that's it. Essentially, that's how easy it is to send snips using SecretToolkit. So you don't really have to think about anything super special when you do this. SecretToolkit does a lot of stuff for you in that regard. Of course, you still need to handle all of the math for the perps and so on, and for the positions, etc. But when it comes to snips, it's usually just trying to leverage SecretToolkit. And it's, as you can see, it's super simple. So it's here on the Netflix access manager source execute at 950 something. And using this, I would recommend, for example, if you want to see how you handle this, you can also just look at snip 20 and just look at where the interactions are happening with this. as you can see, that's actually coming from SecretToolkit, and it's one of the easiest to use things that you can use from SecretToolkit, I guess. Exactly. So as you can see, it's pretty easy to use snips when you're having SecretToolkit. If not, then I definitely wouldn't recommend it. There's actually a way, but it's super inefficient, and SecretToolkit is very nice and tried. Swiss Army knife for us. And lastly, we can also look at Shade maybe and look here for their contracts, because it's obviously a Shade SCRT Labs Hackathon. So of course, let's look at Shade stuff as well, which I quite like. Let's go into staking and into their source. And let's see in their execute. So for example, it's a lot of interesting stuff. For example, it actually can receive some token here. For example, in this time would actually be Shade. Let me see. Now that's actually for staked secret, I think. But as you can see, it's like a lot of interesting stuff that you can see here. I think most importantly, we can look at how we handle snips here. Okay, so it's actually internal. Yeah, no, that's totally fine then. Then we can also look at something else that I wanted to show, which was the queries.
I was gonna say that basic staking contract. I think that's for Shade staking, not stake secret. Just that's
it's actually Shade. Yeah, okay. I actually got myself confused right now. No, I actually thought it was Shade staking, and then I got confused now and thought it was stake secret. Oops. Thanks for that tip. But aside from this, this is actually just still quite a nice contract. So people can definitely take a look at how you would actually do the math handling here, because I think that's actually pretty valuable to look at it from this direction, I'd say, when it comes to the math handling that you have in here, especially for these reward calculations and so on. There's definitely something you can take out of this if you're not quite sure how to do this. But the thing is, the math stuff, that if people are coming over from cosmwasm, doesn't really change. There's no real difference for the maths. The main differences are in the access control and cryptography handling, but not when it comes to the math, really. So I think most people are pretty experienced in that regard. If not, you can basically look at this contract here and just have some idea on basically how most of the math is handled inside of these contracts. I think that's a pretty good starting point for most to just see. Good thing is, at least the hackathon still lasts for, what is it, over 2 weeks. So there's a lot of time that you can really use to look at these details. Another thing that I want to show though is actually the queries that we have here. For example, we have stuff that's public. So for example, the reward pools, that's all public functions. So if you just query these, you will definitely get just the answer. That's it. But then you can actually use some more information, which is, so you can actually look at stuff from the users as well and for the rewards as well. But these are not actually protected by viewing keys or permits. But aside from this, I think if you want to do more sophisticated, let's say, queries for pools, this is where you should basically look at, and then how they are doing it. I think this is one of the best ways to have a good idea of how to do that, even though this is not using permits or viewing keys. This is stuff basically for public queries, but I still recommend using it in secret if you want to do, for example, to show pool information, perps information, for example, how many open longs and shorts do you have and so on, without revealing too much. But if you want to do the permission viewing, you can of course come back to here and look at the queries that you have using viewing keys and permits. So basically you get the whole array. You get public queries, you get private queries, I'd say, and you have all of the interesting maths and most important thing basically here as well. Yeah, I think that's a pretty good starting point for anyone who wants to continue, who wants to look at these contracts. I think that's a super nice starting point, and that's basically what I wanted to get across today. Having a good starting point for people to look at and see what they can basically take out of these contracts, because this stuff is implemented was implemented like for quite some time, and there's super valuable stuff in there that makes a lot of headaches go away. So there's a lot of stories that even I can tell about it. But I think that's it for me. Let's see if we have questions.
Thank you for that, Alex. This was super helpful, and we'll be pulling all of the example contracts and anything from the presentation. We'll be able to pull that and link it on the YouTube video, so people will be able to have access to that. Just out of curiosity, I think you were one of the first people to utilize our new open source SDK, Shade.js. Did you end up utilizing the batch queries? I know you were talking about like ways to query different types of data.
Yes, definitely. Yeah, we actually use these. I can actually show it to you in the. I think that's actually a good idea if we actually include this as well in the example. So I actually have it here in the dashboard. So what we use this in the dashboard, and we do the batch queries exactly. We have it in the services somewhere. I think it's a wallet service. It's actually batch queries. So for example, but that's done it's a mix of JavaScript and using Shade.js. So for example, we're using these batch queries here, and this is actually from Shade protocol, Shade.js. So what we can do is we can query a lot of the, as you can see here, a lot of the S tokens, SCRT, SUSDC, SAUSDC, SAUSDT, and so on, all at once. And what Shade.js does is essentially give us, I basically just define each query here on the top. So an ID, a contract, and a query message, which is just getting the balance. And then I can use Shade.js to create me one huge batch query, which I can then which then queries the stuff for me and gives me out the results, as you can see here. So yeah, which is super, super nice. Yeah. So that's definitely also something pretty valuable. We can also use this as an example, but this is more of a front-end thing. So I wasn't quite sure if I wanted to include it into the smart contract development itself.
Yeah, I'm just glad you pointed it out. Just so if individuals are looking at trying to
yes,
do some like really big perform really big queries, they've got some optionality for how they can do this. But appreciate all the work you've done today in presenting this. This is great, and I think this is going to be super helpful for all of our participants. And like you said, we've got a little over, it's almost 3 weeks. We're likely going to extend the hackathon just because of the US holidays that were observed. We're likely going to extend the hackathon another few days, maybe a week or so. And we'll make sure to let everyone know. But yeah, there's still plenty of time to continue working on this.
Okay, awesome. Sounds very nice. Yeah. So a lot of time for reading more code examples, getting to know stuff with permits more and viewing keys. And yeah, I think that's a good starting point. Also, if you want to look at more JavaScript stuff, Shade.js is exactly the way to go because it actually has some quite nice, which I didn't try out though, some simulations for swaps and so on. And maybe people can use this to their advantage. But also, if you just want to do like batch queries, so like just query stuff all at once, doesn't even have to be balances. Could be just positions of perps, for example. So if you have, let's say, 10 different perps that are currently running, and you want to see the position of your position basically in all of them at once, these batch queries would be pretty easy to implement, and it would allow you to just have one query that gives you the position of all perps that you're basically in. That makes a lot of sense to do. It's actually very okay to implement using Shade.js. So I would definitely include this as well if you can, or if there's like some guide, we could actually include this as well, because I was actually the first one to implement the batch queries, and it's actually super easy. Like it took me like one That was like more 2 hours of testing. 2 hours like to just implement everything, and test it into my stuff, because I had to like do some adjustments for the mapping here. The mapping, basically getting this stuff was just the easiest stuff, actually. Getting the batch query itself, it was mainly just getting the mapping correct and so on. For the dashboard itself, which took the most time. So yeah, but this was definitely something that's super, super valuable and improved the performance like a ton.
Yeah, I think this will also be helpful because, when we're talking about users are going to be providing liquidity for traders to use to open up these leverage positions. If you're a liquidity provider, being able to query all the pools you're providing liquidity in, being able to query all the open positions you have, especially for active traders, I think this would be really helpful. And we know with observing other perpetual swap exchanges, these are users who are very active. So it's going to be a lot more active querying, a lot of activity for changing, updating positions. So being able to minimize the amount of load on the nodes you're querying is going to be really helpful.
Let me close that window then, I think. Yep. Okay.
Well, cool. I'm going to go ahead and